Honored algebra students, Mr. Lawrence here, and I think I just set a record, but I'm sure Austin can beat me anyway. This is your review, and it's going to be a long video, ladies and gentlemen. I may break up into two parts, I may not. We'll see how it goes, just for saving, but I will post both parts on Thursday. Friday, I'll be in class with you. We'll go over some stuff, and then you'll have several days to review. You'll have to have some maturity. Guys, are you listening? Are you listening? You're going to have to study over the weekend. You can't use this, well, I'm only in eighth grade, immature excuse. You've got to do your best. I know some of you are going to do your best. Some of you I'm worried about. You're going to kill your grade this quarter. This quarter's been so screwed up because of the snow days and continuity. We have to get this tested. We have to test on these materials and then move on to the next thing. But you have to prepare. It's not difficult. It'll take some time, but it's not difficult. Put down the Xbox controller or whatever it is that's distracting you and get it done. All right. First of all, let's talk about what we're going to talk about. So we're going to solve absolute value equations and inequalities. Remember, with inequalities, we'll have to graph them on a number line. Then we're going to graph absolute value equations, right? Those will be the V's. Remember doing the V's. We'll talk about domain, range, and functions. Then solving systems of equations and inequalities. That should be pretty simple. You just took a quiz on it. And then parallel and perpendicular. And of course, the parallel and perpendicular is tied to the systems of equations because sometimes we have consistent and inconsistent systems, right? And we'll briefly review what that is. And then we also, if it's consistent, it might be dependent and it might be independent, right? Okay, we'll get to that. And I'll probably split this into two videos so that it can save. But anyway, here we go. Remember that when solving an absolute value, the definition of absolute value is the distance from zero on a number line. There are usually going to be two parts. A lot of you will do this equation, you will do it wrong. You will do 2x plus 5 equals 10. Oops. And then you'll subtract 5 from both sides. 2x equals 5. Divide by 2. And you'll say, x equals 2.5. And then you won't know why you only get half credit. All right? Because you forgot there is a second part. Or 2x plus 5 equals negative 10. I would highly recommend writing down both parts before you start to solve so that you don't forget. I'm going to subtract 5 on both sides. 2x is going to equal negative 15. Dividing by 2 will get me x equals negative 7.5. And remember, our answer is both parts. Austin, how many parts does it have? 2! It has 2. Brad, were you listening? Hopefully. All right. Now this is an and I know like a lot of you like to do it as two sentences. So I'm going to go ahead and do it as two sentences. I would prefer to do ands as one sentence. But I'm going to write 3x minus 1 is less than 16 and 3x minus 1 is greater than negative 16. Not only do I have to change the sign, but I have to flip the symbol, right? And so now I can go ahead and solve. And I'm going to get 3x is less than 17 and divide by 3. And so x is going to be less than 5 2/3, I believe, right? And I'll solve over here, add 1. I'll get 3x is greater than negative 15. Divide by 3, divide by 3. X is going to be greater than negative 5. Okay, so I have a number line here and negative 5. And here I'll have 5 2/3, right? And why are they open points? Nick knows, because they're not equal to. Now, ands should be in the middle, but I can test where are the numbers that are less than 5 2/3. Well, 4 is less than 5 2/3. Is 4 greater than negative 5? It sure is. Remember, ands usually look like that, except for those unusual circumstances. Okay, this problem here is an or. It's a great or. So when I get the graph, I'm expecting something like this, right? We'll go away from each other, and actually the points will be closed. I'll bet Maddie can tell you because it's equal to. I'm going to do it the same way. I'm going to write down 1/2 x plus 2 greater than or equal to 7. or 1/2 x plus 2 less than or equal to -7. And we're going to subtract 2 from each side, and we'll get 1/2 x greater than or equal to 5. Going to multiply both sides by 2 to get x is greater than or equal to 10. Or I'll subtract 2 from both sides, and I'll get 1/2 x is less than or equal to -9. Multiply both sides by 2, and I will get x is less than or equal to -18. Now, remember, I would only flip the inequality if I had multiplied or divided by a negative, which I did not, so no problem. So on my number line, I need to show -18. I need to show 10. There'll be closed points, as we mentioned before, and ors go out. But I can test, where are the numbers greater than 10? Well, they are to the right of 10. And where are the numbers less than -18? They're to the left of -18. If I would take a number in here, say 0, and put it in, I would get 0 is greater than or equal to 10. Not true. 0 is less than or equal to -18. No way is that true. So you see no numbers in between -18 and +10 satisfy either part of the inequality. None of them. Okay, let's take a look at this one. I'm done. I know the answer. Remember, this is a distance number, right? And this is from some center. So this is from a center on the graph, and this is the distance. And I need to know the numbers that are less than -5 units from my center, which I believe my center in this one is going to be 1.5. Well, I can't have things smaller than a negative number, not when I'm talking distance, so this has no solution. No solution, right? Okay, if I had asked for greater than or equal to, I would have ended up with all real numbers. Okay, but in this case, since it's less than a negative number, I'm going to get no solution. All right, I really haven't done that many problems, but man, that time goes quick. Okay, here we go. We're going to graph absolute values. Remember that we have a vertex. The x-coordinate of the vertex is whatever makes this 0. What makes x minus 4 0? Well, 4 does. Now the y-coordinate is right here. Remember, it's kind of like y equals mx plus b. Well, this is the b. So it's at -2. So my vertex is at 4. 1, 2, 3, 4, -2. There you go. All right, now this number is like my slope. It's a -1/3. And remember, I'm always going to apply it to the numerator when I'm doing absolute value. The negative means it's going to open downward. So I'll go down 1 and write 1, 2, 3. Now because of symmetry, I go down 1 and back 1, 2, 3. And so I'll have that and 1, 2, 3 like that. And so my graph will look like this. All right, there you go. Had this slope been positive, the v would have opened upward. Had the slope been something like this, let's see here, let's do y equals 2 to absolute x plus 1 plus 3. Let's graph this one real quick. My vertex is going to be -1, +3, right? What makes that 0? X plus 1 equals 0. Subtract 1, x will equal -1. Okay, so my vertex is -1, +1, 2, 3. All right. My slope is 2 over 1, so I'll rise 2, run 1, rise 2, run 1, and then, of course, on the other side, I do the same thing, and I get a V that looks like this. It's a lot skinnier, isn't it? Doesn't seem as wide. Yeah, and it's opening upward because it's positive. Now, this will lead us into our next topic, domain and range. Okay, and I'm going to talk about the domain and range of these graphs here. So the domain, remember, is your x values. Domain are the x values. And I guess I should do the domain for both of them so we don't get confused. Remember, to test domain, we like to use a horizontal line if possible if we're looking at a graph. Oh, excuse me, a vertical line, excuse me. Okay, so let me get my vertical line out and let me test the upward or the downward opening V because that's the one I graphed first. It's the green one. Is there any x value that will not be a part of that function? No, there's not. You might say, well, -10. Well, won't this eventually hit -10 if I extend it long enough? Sure it will. If I said -1,000, if I extended it long enough, eventually it would hit. Okay, so my domain for the downward opening one is all real numbers. Okay, how about the range? Well, the range are the y values, right? I might have to give myself some room to write here, pardon me. And for that, I need a horizontal line, and that's way too fat. I guess I can use it. I just don't like how fat it is. Let's use a thinner version of it. There we go. Okay, so there we go. Let's test this bottom one. Are all the y values included? I don't think so because I'm hitting all the y values down here, but when I come here, that's like the maximum y value. Then I'm not hitting the downward opening V anymore, am I? So what is the value of y at that point? Well, that's -2, isn't it? So the range is going to be all real numbers such that uh, y is less than or equal to -2. Y can be -2, it can be -3, -4, -4.5. It can be any of those, -10, way down at the bottom, -1,000,000. But it can't be 1, -1. Can't be 0, can't be a half, can't be 1. Okay, can't be any of these values for the downward opening one. All right, let's test the domain for the upward opening one. And I think, again, we're going to get all real numbers in this case. Now, many of you have asked me, is it always all real numbers? No, 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 no. With the absolute value functions opening upward or downward, it might be, but don't start to think, oh, it's always all real numbers, because when you get into more complicated functions next year or in Algebra 2, they won't be all real numbers. Okay, let's test the y values here, the range, and it looks like I'm not hitting the upward opening V down here. I hit it there and upward. Well, what's y's value there? Oh, that's 3. So the range is going to be all real numbers such that y is greater than or equal to 3. And there's your domain and range. Okay. I'm not going to do number 6a, domain and range. I'll leave that to you. I will do B. The domain, in this case, is going to be all the x values, and I don't list them more than once. 0, -1 are all the x values. The range will be all the y values. And remember, we like to write them in ascending order from smallest to greatest. And there we go. Now, one thing I didn't mention, are they functions? Well, let's test it. Let's test it. Let's test this one. Remember, for a function, x can only go to at most 1 y. You can't have the same x value going to any more than 1 y value. So check this out. Let's do the little picture like this. Where's our domain? And we have 0 and -1. And then we have the range is 5, 7, 8, 5, 7, and 8. Okay. Now, where does -1 go? Well, according to my data right there, -1 goes to 8 and maps onto 8. 0 maps to 5. 0 also maps onto 7. This is not a function. This is only a relation. This should be reviewed for all but one of you. Relation. This is only a relation, not a function. Okay, let's back it up here and let's talk about, are these functions or not? Well, is there any x value in either of these v's that will have more than one y value? The easy way to tell with a picture is called the vertical line test. You take that vertical line that we use to determine, and you see, does it hit the V in more than one place at the same time? No, it does not. If it did, it wouldn't be a function. So yes, both of these are functions, both the green one and the blue one. Okay. Now, some of you might be wondering, well, wait a minute, Mr. Lawrence, show me an example of one that's not a function. All right, there you go. Let me get these out of the way. You see this, this V that's kind of opening to the right? If I put my vertical line here, I intersect the V in two places, don't I? I intersect the V right here, and I intersect the V right there. And maybe I should send that to the back so we can still see the V. Order, send to back. There you go. Yeah, that worked. Okay. So what's X's value there? Well, X's value is 0. And 0 has two numbers. It has 0, 2 and 0, 6, no, 3, 5, sorry. 2, 3, 4, 5. There we go. I was counting. 0, 2, and 0, 5. If I move the V over to the right a little bit, oh, excuse me, not the V, but the vertical line, if I put it here where X is 1, am I still hitting two values? I sure am. Okay. I'm hitting at 1, 7, and I'm hitting at 1, 1. So this is only a relation, this one here. Okay, now, by the way, to be a function, it only has to hit two y's for one x one time. It doesn't matter if it has it 10 times. All right, I'm going to stop this part of the video here. I will get this posted, and then I'll record the next one for you. Mr. Lawrence, temporarily signing off.